Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the June 2024 R paper, replacement or regional paper. I don't know what it stands for, but it's the alternative to the June 2024 normal paper, slightly different questions. This is from the International A-Level Edexcel Pure Mathematics P2 exam. And here, question number 8, part 1, part A, in an arithmetic series, keyword, which is bold. The first term is A, the common difference is D. Show that Sn equals n over 2 in brackets times 2a plus in brackets again n minus 1 close bracket d times d and close the main bracket. So this is basically the sum of the first n terms of an arithmetic series which has a first term a and a common difference d. Right, so an arithmetic series is one which increases by the same amount each time or decreases by the same amount each time, has a common difference. So for example, 2 plus 5 plus 8 plus 11 has a first term of a and a common difference of 3. Okay, or you could have something like, for example, 7 plus 5 plus 3 plus 1 plus and so on. This has a common difference of minus 2, first term of 7 and a common difference of negative 2. Right, so those are examples of arithmetic series. Now, we want to find, or we want to prove basically this formula for the sum of the first n terms of an arithmetic series which has a common difference of a of d and a first term of a. Now, in order for us to understand this in a kind of very comprehensive way, I'm going to go back in time to 1777, probably 85 or something like that. Okay, 85, something like that. There's a guy called Carl Friedrich Gauss who was born in Austria in 1777. So when he was in primary school, let's say he was about 9 years old, say, he was in a classroom. He was having a math lesson, and the teacher wanted to do some work. He wanted to do some marking or something like that, and thought of a way of keeping the class quiet and busy such that he could complete the task he had to do, and then he would deal with the class. But he needed something that would keep them busy for a little while. So what he decided to do is he decided to ask the class to find the sum of the first 100 integers. So he basically said to them, add together 1, 2, 3, all the way to 100. So 1 plus 2 plus 3 plus 4 plus 5, all the way to 100. Okay, so of course most of the students, or I guess all of the students, would have started off by doing 1 plus 2 is 3, plus another 3 is 6, or 1 plus 2, that's 3 here, plus another 3, that gives you 6 now, plus another, plus 4, that gives you 10, plus 5, 15, and so on. And they'll keep going, and they would be going, about doing this, and, they would have, there's no calculators in those days, so they'll be doing this mentally, and it would take them a bit of time. But surprisingly, one of the students, who was this Carl Friedrich Gauss, put his hand up and said, "Sir, I've got the answer." How did you get the answer so quickly? Thought my plan now. So basically, he explained how he got the answer. This is what he did. Right? So this is not the proof of this formula, but it gives us an idea of how to prove this formula, which we're going to do after we've shown this. So basically what he said was, I wrote down the sum of the first 100 numbers like this. I put 1 plus 2 plus 3 plus ... and then the last, say, 3 numbers, 98 plus 99 plus 100. But then I wrote down the same line but back to front. So I started with 100 plus 99 plus 98 plus, and then I had here 3 plus 2 plus 1. So all the numbers in between are there as well. So this is the sum of the first 100 numbers, and this is the sum of the first 100 numbers again, the same sum, but just written backwards, back to front. And then what he did is he basically found the actual sum in this way by adding these two lines. So this is line 1 and this is line 2, and he added line 1 and line 2 together. So he got the sum of 100 numbers plus the sum of 100 numbers again. That's 2 times the sum of the first 100 numbers when you add these two lines together. And he did 1 plus 100, which is 101. 2 plus 99, which is 101. 3 plus 98, which is 101. And if we carried on 4 plus 97, it will also be 101. In fact, every single term, when we add them, those pairs together, will give us exactly the same sum, which is 101. Okay, 101 plus 101 plus 101. So that's a very kind of important little finding now, because we have basically, if we think about it, we have 100 numbers that we're going to add together. I want to add it together 101 plus 101 plus 101 100 times, which means 100 times 101. So 2 times the sum of the first 100 numbers is 100 times 101. Okay, so if you want to find what that is, we can just do the sum of 100 numbers, therefore, is going to be, now we can just add 2 zeros to this and divide it by 2, right? Because that 100 adds 2 zeros are divided by 2. And so 2 into 10 goes 5 times. So 2 into 10 goes 5 times. 2 into 10 goes, 2 into 1 goes 0 times. 2 into 10 goes 5 times. You got the 0 at the end. So it's 5,050. Okay, 5,050 times 2 gives us 10,100. So this is the sum of the first 100 numbers. Okay, and the student got that much quicker than the ones that were adding all the numbers together, right? So this does not answer our question here, right? It's just like a little foundational little, demonstration to give you an idea of how we're going to arrive at this this formula for the sum of the first n terms. Okay, so I'm going to get rid of this now, and then we're going to actually answer the question. This hopefully will give you an insight and an understanding of how it works. All right. So first thing I'm going to do is I'm going to say, okay, what to find the sum of the first n 100 numbers. Sorry, the first n numbers when we have a first term of a and a common difference of d. So if you have a first term of a and a common difference of d, so the first term, I'll just write down here, just the first term would be a. Okay, the second term, if the common difference is d, you have to add d to that. To get the third term, we'd have to add another d. So you have a plus d plus another d, which is a plus 2d. Okay, you have to add another d to it, right? And the fourth term is going to be a plus 3d. And if you carry on, the nth term, if you look at the pattern here, if it's 4, that's a 3. If it's 3, that's a 2. If it's 2, that's a 1. If it's 10, that's a 10. That will be a 9. The 10th term would be a plus 9d. So the last term will be a plus, or the nth term will be a plus whatever term is here, which is n minus 1 times d. Take 1 away from that number and then multiply by d. Take 1 away from that number, then multiply by d. So the nth term would be a plus n minus 1 times d. Okay, so the first term would be a. The second term would be a plus d. The third term would be a plus 2d. Okay, so I'm just going to put, I'll just write it like that for now. And then I'm going to have, let's say the 98th term would be, let's write it like this, 99th term and the 100th term. So the 100th term would be a plus n minus 1 times d. Sorry, not the 100th term, the nth term. We're using n now. So this is the nth term. A plus n minus 1 times d. Now, the term before the last term is n minus 1. So just like we did this, we took n and we took 1 away from it and then multiplied by d. This is going to be a plus, taking 1 away from n minus 1 is n minus 2 times d. Okay. That's n minus 1 term. And the n minus 2 term, the two terms before the end, is going to be a plus n minus 1 minus another 1, which is n minus 3 times d. Okay. Now, I'm just going to change the color of this for a second. So here we have a plus a plus d plus a plus 2d plus, and then we're going to have plus a plus n minus 3 times d plus a plus n minus 2 times d plus a plus n minus 1 times d. Okay, so now what I'm going to do is I'm going to write down the same sum, but I'm going to write it back to front. So I'm going to put the sum of the first n terms is a plus n minus 1 times d. And I'll have a plus n minus 2 times d. Just writing this backwards. And I'll have a plus n minus 3 times d. And then I'll have a plus 2d, a plus d, and a. And I'm going to write them as the sum of all of those together. So that's going to be a plus here, a plus here, a plus here, plus here, and there, and there. Okay, so now I have these two lines, line 1 and 2. Okay, this is line 1 and line 2. So I'm going to do exactly the same thing. I'm going to take line 1 and add it to line 2. So I'm going to get Sn plus Sn, which is 2 times Sn. 2 times the sum of the first n terms. Now, notice what happens here. We have a plus n minus 1 times d, which is 2a plus n minus 1 times d. Now, what happens when I do a plus d? I'll just show this here. Plus a plus n minus 2 times d. What does that give us? Well, have a look. A plus d. Well, let's just simplify a bit first. A plus a is 2a. So we have a plus a, that's 2a, plus d, plus, let's expand this bracket. We have nd minus 2d. What do you notice here? That gives us 2a plus, and you have d minus nd. So you have n 2d. So nd, and you're going to have d minus 2d, which is minus d. So what does that give us? That gives us 2a plus, you see the common factor here is d. I'll write it over there. That'll be n minus 1 times d. Exactly the same as this. As we saw before, when you added them, you got the same thing, which was 101. Now we're going to have again plus 2a plus n minus 1 times d. Plus, and again, if this is a plus 2d and a plus n minus 3 times d, you have a plus a, which is 2a, you would have 2d minus 3d here, because that will be n minus 3 times d. 2d minus 3d is also minus d. You get exactly the same thing again, as we can deduce now, 2a plus n minus 1 times d. So we can see we get exactly the same thing. So when I add these together, I'll also get a plus n minus 1 times d. Sorry, 2a plus n minus 1 times d, plus another 2a plus n minus 1 times d, plus 2a, sorry, should be a bit neater than this, plus 2a plus n minus 1 times d. Okay, so each of these give us exactly the same thing, just like when we added together, when it was 1 to 100, we got 101 each time. Here we get 2a plus n minus 1 times d each time. So now what we can see is we have altogether n terms. In total, altogether we have n terms. Okay, so we have 2 times the sum of the first n terms. If I want to add all of these together, I've got the same thing added together n times. So it's n times 2a plus n minus 1 times d. And then all I have to do now to find the actual sum is divide both sides by 2. So it's n over 2 times 2a plus n minus 1 times d. And that's exactly what we had to prove. N over 2 times 2a plus n minus 1 times d. So that is the proof for the sum of the first n terms of an arithmetic series with a first term of a and a common difference of d. Okay, so that basically goes through that. And I hope the earlier demonstration gave you a more clearer idea, because when you've got these letters and stuff, it's a bit more abstract. So hopefully that gave you the idea of how it works. So that's 8 part 1, part A. Now we're going to go to 8 part 1, part B. So it says hence, it means using what we just found. So I'll just leave this visible. Using this, what we've just been given, find the sum of this series. Now there's multiple ways of us actually answering this question. There's many ways we could do it. All right. Now, first of all, this must be an arithmetic series, because we have to use this formula. So hence, so obviously it is. As you can see, every time you're going down by 8. And then you're going down by 8 again. Yeah. So here the common difference is -8. Be very careful here. Common difference is -8. Why? Because every time you're going down by 8, as you can see from one term to the next, take away 8. Then take away 8 and so on. So we know it's definitely an arithmetic series. So here the first term is 900 and the common difference is -8. Okay. Now there's different ways we can work this out. Okay, first of all, we need to find the value of n. We need to find how many terms there are, okay, in this. And there's a couple of ways of doing that. One of the ways of doing that is to basically call this one the nth term. Okay, so we know that the nth term, as we discussed earlier, is given by a plus n minus 1 times d. And this is given in the formula sheet, actually. Okay, so for an arithmetic series, this is the nth term. So we know the value of the nth term is 500. We know the first term is 900. And we know the common difference is -8. So we can just, replace these values. And the only thing we don't know is n. So we can say 500 is equal to 900 plus n minus 1 times -8. So you have 500 minus 900, which is -400, equals minus 8n plus 8. So we can do the following. We can say, okay, 8n is equal to 408. So n is equal to 408 divided by 8. So 8 goes into 45 times, 8 goes into 1, and there's no remainder. 8 goes to 8 1 times, 51. So we know that the number of terms is 51. Okay. Another way of doing this is actually subtracting the two numbers. So you can say 500 minus 900 and divide it by the common difference, which is -8. And that's going to give you minus 400 over -8, which is 50. But that's the number of gaps between each. When you subtract two numbers, you find the number of gaps between them. So this will tell you that there's 50 terms. There's 50 gaps, but the number of terms is always one more than that. If I have 1, 2, 3, 4, if I subtract them, I get 3, but there's actually 4 terms. So I have to add 1 to that. So we can say there's 51 is the number of terms. So a couple of ways we can work out how many terms there are. But in the end, we end up with 51 terms. So we know that n is 51 now. Okay. So once we know that n is 51, then we can use this formula. We can say that the sum of the first n terms, therefore, is going to be, as we said, n over 2 times 2a plus n minus 1 times d. So that's going to be n, which is 51 over 2, times 2 times 900, okay, plus n minus 1, so it's going to be 51 minus 1 times -8. Careful of the minus signs here. So you can just stick this all in your calculator and get the answer. So you're going to have 51 over 2 times 2 times 900 plus 50 basically times -8. Okay, 2 times 900 plus 50, 50 minus 1, 51 minus 1 times -8, and that gives you a sum of 35,700. Okay, that's one way of doing it. Alternatively, we can use an alternative form of this. So this is basically also the same as n over 2 times, and what we can do is you can split this up into two parts. We can say this is like a plus n minus 1 times d. So a plus n minus 1 times d is basically the same as this. So I can write this as a plus, and a plus n minus d is actually the nth term, the very last term. So we can write here L, meaning the last term. Okay, and that's another very convenient formula if we know the first term and the last term. Okay, and the number of terms. So a plus L. This is a nice, easy formula to use if you know the last term and you know the number of terms. So this would be 51 over 2 times the first term, which is 900, plus the last term, which is 500. Okay, we know the first term, we know the last term, we know there's 51 terms. And that should give us exactly the same answer. So we do 51 over 2 multiplied by 900 plus 500, and we should get exactly the same answer, 35,700. So that's an alternative way of answering this question. Both of them would be perfectly fine. Okay, and that formula is also in the formula sheet as well. Okay, for the arithmetic series, as you see. So that concludes question 8, part 1, A and B. And I think there's a part 2, which is about geometric series. Okay, should I do it as a separate video? No, I'll just do it together as one series video. All right, so it says, given that the first 3 terms of a geometric series are k plus 4, k minus 2, 11 minus k, where k is a constant, show that 2k squared minus 11k minus 40 is equal to 0. So it's a classical type of question. So this is a geometric series. A geometric series is where you have what's called a common ratio. Common ratio, okay, which is normally called R, right? And an example of a geometric series would be something like, for example, 2, and then say 6, and then say 18, and then 54, and so on. Right? So this type of series here, every time you have to multiply by the same number each time to get to the next number. Okay, and to deduce whether something is a geometric series, you divide the term by the term before it. It should give you the same answer. So you have a common ratio. So if I take 54 divided by 18, it will give me 3. 18 divided by 6 will give me 3. 6 divided by 2 will give me 3. So if we apply that to this, the common ratio here would be 11 minus k divided by k minus 2. And it will also be the same ratio, k minus 2 divided by k plus 4. That's a common ratio. So that means these two fractions must be equal to each other. So we can say 11 minus k over k minus 2 over k minus 2 gives us exactly the same ratio as k minus 2 over k plus 4. So if we cross multiply both sides by k minus 2 and k plus 4, you end up with, on this side, 11 minus k times k plus 4, and on this side you end up with k minus 2 squared. So this gives you 11k plus 44 minus k squared minus 4k equals, if you square this bracket, you're going to get k squared. Then you multiply these together and double it. That's minus 4k. Then you square this last number, gives you plus 4. Okay, let's simplify this side as much as possible first. So we have 11k minus 4k, which is 7k. So we have 7k plus 44 minus k squared equals k squared. Take away 4k plus 4. Now we can show that this is the case. We got k squared. I'll get rid of everything from this side, so the k squared is positive. So I'm going to add k squared to both sides. That's 2k squared. I'm going to subtract 7k from both sides. So minus 4k minus 7k is minus 11k. And I'm going to subtract 44 from both sides. So it's 4 minus 44, which is negative 40. So I end up with what we had to show. 2k squared minus 11k minus 40 is equal to 0. That's what we had to show. And that gives you the answer to part A. And then it says, given also that the series is convergent, find the value of s to infinity. Now the sum to infinity of a arithmetic series, of a geometric series, sorry, is given by a over 1 minus r. This is again given to you in the formula sheet. But what does it mean by convergent? Okay, what it means is that the sum gets closer and closer and closer to a certain value. And that only happens when the magnitude of the common ratio is less than 1. Okay, because then each term gets smaller and smaller and smaller as you go along. If you multiply something by, for example, a half, if the terms are half each time, or 1/3 of what they were each time, if the common ratio, what you have to multiply by each time, is always something less than 1, then what will happen is that the value of the terms will get smaller and smaller and smaller and smaller. And as you add more and more terms together, the amount you're adding will be so small it won't make much of a difference to the number. So it will converge to a particular value. Okay, so we know that this is a series which is convergent, right? And so what we can do is we can work out the value or values of k for which this is true. and that will help us work out the common ratio. So I'm going to solve this equation. Now, this is a quadratic. I'm going to solve it. You have to show how you solved it. You can use your calculator if you want to, but you have to show that you factorize or use the formula. Okay, I'm going to try to factorize, and this is the way I like to do it. This, I don't know what I call it, the window method, different ways they call it, but I write the first and the last term in here, the square term and the constant in these two brackets. I know that these two numbers and these two numbers must give us the same product, and these two numbers, when I add them together, must give me 11k. So I'm looking for two numbers whose product is negative 80k squared, and the sum of those two numbers is minus 11k. So I think of ways of getting 80. We got 8 times 10, that won't work. We got, what other ways of getting 80? We got 15. We got 5 times what gives you 80? 5 times 16? That's 50 plus 30. Yeah, that's the one. 5 and 16. If I subtract them, I'm going to get 80. If I add them together, one of them, they have to have different signs. So I need to get, so it's going to be negative 16k and plus 5k. Those two numbers, when I multiply them together, I get negative 80k squared. When I add them together, I get negative 11k. So now what I'm going to do, these two terms, the common factor from them is 2 and k. So I'll write that out there. 2k times k is 2k squared. 2k times minus 16k is minus 8. Or 2k times something gives me minus 16k. That's going to be minus 8 there. And k times something gives me 5 plus k. That's going to be a 5 plus 5 there. So I've got 2k plus 5 times k minus 8 equals 0. So in this case, we can say either 2k plus 5 is 0 or k minus 8 is 0, in which case k is equal to 8 or k is equal to negative 5 over 2. Now, we know the common ratio is given by these two. I think this is a bit easier to use, so I'll use r equals k minus 2 over k plus 4. The common ratio is k minus 2 over k plus 4. Okay. In fact, we can actually we don't even have to do that. Let's just write down what the series is now. So the series is going to be, it's going to be k plus 4. So you have k plus 4 and k minus 2. And you have 11 minus k, right? 11 minus k. So now let's try to put, if you put 8 in here, you're going to get 12. 8 plus 4 is 12. You're going to have 10. And then you're going to have 11 minus k, which is 3. Okay. Is that right? Put 8 in here. That's 8 plus 4 is 12. 8 minus 2 is, sorry, this will be 6. That's going to be a 6. And that's going to be 11 minus 8, which is 3. And we can see here, to get from one term to the next, we have to multiply by a half, multiply by a half. So here the common ratio is going to be a half. Okay, so it looks like that this is the right common ratio. Okay, if we put k as minus 5 over 2, I don't think it's going to give us the right series. We can try it out if you want to. You can say minus 5 over 2 plus 4. That's minus 5 over 2 plus 8 over 2. That's going to be minus 3 over 2. Okay. And you're going to have minus 5 over 2 minus 2. That's minus 5 over 2 minus 4 over 2. Okay. That's going to give you minus 9 over 2. And then you have 11 plus 5 over 2. That's going to be 22 over 2 plus 5. That's 27 over 2. So if you, that's going to be positive here. Yes, that doesn't seem to be giving us anything that we need. So obviously, the common ratio is a half. That is going to be what gives us a convergent series. So as a common ratio is less than 1, therefore we can say that the sum of the first, or the sum to infinity of this series is going to be a over 1 minus r. And the first term, as we said, is 12. This is a. So it's a over 1. Sorry, it's 12. Sorry, 12 over 12 divided by 1 minus half. Okay, so it's going to be 12 divided by half, which is 24. So the sum to infinity of this series is equal to 24. Okay, if we use minus 5 over 2, let's just do this properly. I don't think I did it very well over there. That's going to be 8 over 2. 8 over 2 is 4. And you'll have minus 5 over 2 minus 4 over 2. And you'll have 11, which is 22 over 2 minus 5 over 2. So this will give you, as we said, 3 over 2. And this would give you minus 9 over 2. And this would give you 27 over 2. So here the common ratio would be a negative value. It would be 27 over 2 times 2 over minus 9. So it's going to give you negative 3. Here the common ratio is negative 3. If you multiply by negative 3, you get this. You multiply negative, So here the common ratio, its magnitude is greater than 1. Therefore, there's no sum to infinity. So for this value of k, you have a geometric series, but the common ratio is the magnitude of the common ratio is greater than 1. Okay, the magnitude of the common ratio is greater than 1. Okay, so it won't get, it won't become a really small, tiny value. All right, and in this case, the magnitude of the common ratio is less than 1. When you end up with k equals 8, you get this series. So therefore, this gives us a sum to infinity, which is 24. So there's the answer to this question. I hope that was clear. I think that completes this question. So this part was all about a geometric series, sorry. So that completes this question. Other questions from this particular paper can be found in the playlist that will appear on the top right of the screen at the end of the video. Other questions from the topic of series you will find in the playlist over here. You can subscribe to my channel by clicking on this link. And at the top here, you can watch a video which shows you how to use my channel to find what you're looking for. Thank you for watching and see you soon.